Right, so I've got a bit of a special video to do. You'll notice here two Siglent boxes. The first one is the one I'm going to be doing a quick overview of right now, and I'll be doing a follow-up video on that as well, to go into a bit more detail. And the bottom one I'll be doing later on as well. Okay. The top one's quite exciting for various reasons, and we'll get into that shortly. But for now, it's a bit of mystery. What is it? What's in the box? Let's go. Right, let's do the unboxing. As you can see, this box is already open. I've already seen the units in here. This has been kindly provided by Taupachi Technologies, Rob, who's the New Zealand dealer, or the distributor in Auckland. And this is just on loan for me to do a bit of a review on, as is the other unit. So they both have to go back to him, which is all fine, but it gives you an opportunity to see this unit and what I'm going to do with it. Okay, so what we got? Well, unboxing, power cord, we have a manual and a USB cable there, and a couple of scope probes. Okay, 200 megahertz probes, which is quite generous, I think. So let's just have a little look before I get any deeper. So here's the manual, and a bit of a clue about this already. SDS 1000X-E series. That's right, it's the E series scope, the brand new one, and I'm one of the first people to see one, because of Rob being generous and letting me borrow it for a little while. So obviously the usual quick start guide stuff there, you know, it's tells you how to calibrate the probes and so on, as you'd expect from a scope. And it's a nice manual. It's nice. Looks like it's got nicely laid out. View panel layouts and stuff. Overview of the front panel controls. Got a disc here with software on it, which I believe has got the control software for use on a PC, so you can control the thing from a PC and view screens and grab screenshots and save setups and reload setups and that kind of stuff, all from the PC. And here is a Keysight. Now, Rob mentioned that this is a bit unusual for some of this gear, where you don't normally get, well, they didn't used to give them with the unit. So this is a Keysight for this unit, so it's awesome. You know, you've had to get one of those with it as well. That in itself is probably worth a bit of money. You know, to get things cowed and have them traceable. And see a bit more about the control setup and troubleshooting guide, and if you need it, like usually, you know, operator error. Usually it's operator error. So okay, so that's a little overview of the manual. Put this back together. So this is only a loan, this isn't mine, and I'm not being paid or anything for this. This is just an opportunity for me to get in and do a review, and this is what the bonus is for me, is to be able to get into it and do it. So let's move this out of the way. My bench is a bit crowded. I really need to reorganise it. It's a bit messy. I've got too much stuff on it now. So let's get out. Here we go. So Rob actually, when I went to pick this up, Rob actually had it out for me and a little bit of a play around before he backs it back up again, so I bring it down. So there we go. Let's get a bit closer. So you've probably seen pictures of this thing anyway online. Layout's a little bit different to the other units. I actually managed to see this side by side with the previous generation, and yeah, this is definitely more compact. It's much nicer in that regard. You know, it's a lot. It's you know, noticeably shorter, things like that. And it's got a nice handle on there which clips in, so that's nice. Controls on the back, trigger out, pass fail option. Obviously, that's a selectable thing in the menus. USB and LAN as well. Obviously cal sealed on there, and so you got dual channel, external trigger input, usual cal, test point, and we shall get onto this shortly. These do have an extra button, which you can see just here, which actually turns some of the menus on and off and stuff like that. So we'll get into that shortly. Right now, I need a power cable, and we're going to power this up and go a bit more detail. Be right back. Okay, I've got the power plugged in. You have to forgive the shadows, it's night time now, and so I've got these feet folded out, tip it back out, you can see, and see it's got the same as my other Siglent here, which has got the little pulsing light when it's got power but is off when it's asleep. So it's a nice little confirmation the power's still on, which is like on my test bench here. I actually have one main switch which shuts everything off. So if I'm not going to be around for, I'm not going to use the gear for a couple of days, I'll flick that off, So let's power it up. So this is the 1202X-E, 200 megahertz, and I feel quite privileged to be one of the first people to actually have a chance to look at one of these and try and review it, and so it's quite lucky. Right, so this has got all kinds of stuff on it. User interface is very similar to my other Siglent here. I'll just power that up. And fan noise, it's not bad. It's actually quieter than my 2102. The 2102 fan is noisier than this one. So, and even that's not that noisy. It's fairly sedate. And this is quieter. That's not bad. I'm quite happy with that. So, obviously 2 channels, so it's turning those both on. Same colour coded to the controls here. I haven't unpacked the original scopes. It came scope probes. I'm going to use my own scope probes, but I'll just have a look and just to compare them in case they're different. So I'll get one out, just have a little look. But I'm going to use my own probes. Just do testing. So you've got little bands on them as typical, switchable 1 times 10 times. And they do look basically the same, so it looks like it's the same probe as what came with my 2102. Looks like the same probe. It's got a different crocodile clip on here though, different kind of housing, but it's going to be pretty much the same thing. Other things are in his bag. Let's have a look. So you obviously got the adjustment tool, some insulating caps, a BNC adapter. A little spring probe for the earth point, and colour rings as well, so you can colour code as you want. So that's all good. Sort of things you expect the probe these days, The BNC adapter is quite a nice touch. That's quite good. So they do come in very handy. Let's pop that back away again. Okay. Lighting's not the best, so we get some more light here. It's marginally better. Yeah, it's not the best, is it? Probably actually worse. Let's just carry on with it. Let's carry on with this. Okay. So, interface is very similar to the previous ones, as I say. They actually work very much the same way. That it's much for muchness in most cases, but so there's my scope here, which I've been playing around with today. So it's sort of a bit configuration's a bit messed up on it right now. For this, I was doing some decoding earlier on. So typical triggering, auto, normal, single. It's on the side here instead. On this scope, it's in the centre. And like this generation had issue with the knobs being really close together, and that's a bit of a complaint by many people. This one, they're all nice and far apart, so that's all good. It makes it easier to use the various knobs. They've also got the shape is different now. They've got a bit like a knurling effect on there, so they're not perfectly round and smooth. And I prefer that if it's got a nicer feel. Okay, so let's say hook up a probe. I won't bother doing calibration on the probe or anything like that. It's, I'll have a look and see what it's like, but I have to get used to these controls and see how we're using. Run, auto. I forgot to use this thing. It's a little bit different to my one. Okay, so yeah, my probe does need adjustment for this scope because obviously you can see the conversation's way off. But ignore that for now. I'm not going to change it. I'm just going to leave it as it is for now. Alright, so let's pretend it's correctly set. Okay, so it's got the usual stuff on here you expect. Roll mode, you can turn it on and off independently. So what's its longest time scale? 100 seconds per division, and all the usual. So what's its fastest time base? Fastest time base is 1 nanosecond. So that's pretty good. Voltage levels. So that is 100 volts per division. I have to actually look, see what the references say it can do. And what's that? 5 millivolts per division. So that's reasonable. It's not too bad. Rating here is 400 volts peak at 1 megaohm. So that's reasonable. It's what the levels you expect. My other scope has got that. My Tektronix has got that. It's a pretty typical level. So what can I do which is interesting on here? There's all sorts of stuff. You can do. There's so many features, and as I was saying to Rob earlier on, my scope here, I've had this now for about 18 months, I think. My SDS, and I haven't even used everything on it. It's got so many features on there. I mean, I tend to do the same kind of things over and over again, so I don't tend to experiment with a lot of those extra features. But it does it. So one thing here is it's got math functions, FFT and so on. So I don't know how good the actual cow is going to be for this. Let's take it back out of there for a second. Actually, I might use a different input source rather than that. Let's fire up something else. Let's fire up this instead. And I'll get my BNC probe, which is actually sitting just here. I'll chuck a higher frequency in there. Wish people wouldn't come into this room when I'm trying to record. Anyway, never mind. So let's chuck this on my Marconi, and I'll do a 10 megahertz output on that. Chuck that probe in there, and let's do half a volt, and I'll turn AM modulation off. Okay, so this is a 10 megahertz signal, okay, at half a volt. So let's just center that and center that. There we go. So this control here is, so the layout's a little bit different to my scope here. So oops, let's try that again. It's a little bit loose, that one. I've used it a fair bit. Let's just really plug that in. Try and get it to stay, it'd be nice. So that's a little bit different to my other scope, so I have to try to get used to where things are on this one compared to normal. Okay, so this is a nice 10 megahertz signal. That's all typical. So let's try and do a math function on that and see how we go. So channel 1, that center frequency is way away if I want it to be. So let's just go. What do you want? 20? No, I want 10 megahertz. Sorry. 10 megahertz. By the way, this is handy, this little keyboard thing which pops up if you're trying to do something a bit quicker. So it's sometimes quicker than just going around with this adjustment here. It's going around and around. It's just a bit quicker than that. So this one here. So that's what it's going to do. Yeah. Right. trying to see what its bands are set up as. So you can adjust that resolution by changing the time base. Alright, so depending on what a time base setting is in, it changes things like the actual division ratio and stuff like that. Okay, so now I can bring this down a bit more. So I haven't played around with the FFT a lot on my scope here. I've only used it a little bit. I haven't really, because I've got a spectrum analyzer here, so I tend to use that. But if you don't have a spectrum analyzer, this could be really helpful to give you an idea what's going on. Okay, so it's just, which I might bring it down a little bit. Forget the right thing. This one here. No, sorry, I'm using the wrong thing here. Scale. So you can change how much of the screen it covers by adjusting the scale range, adjust the range that's visible, so you can get a much wider range of what you're looking at. So this isn't something I've used a lot myself, so it's a bit of a new thing for me. All right, let's put some modulation on this, and I'll show you why in a second. This has got 30% AM modulation on it. You can see the persistence going on there. Okay, so display persistence, 1 second persistence. I like to use colour. I'll do a bit longer. 2 second persistence. Yeah, I think I will. You can see the actual waveform there. So I've got 5 second persistence, sorry. So you can see that effect there when if you change ranges, I'm artificially causing it to show up more. Alright, so with that you can get to see the colour scales here. Okay, so we've got red there, which is a bit brighter to see. Yeah, make it a bit bigger. Alright, so that's a nice feature. I mean, with dots and vectors as well. I prefer vectors myself personally, but it just gives it a bit of a shading rather than lines. You can see the lines running through it like that. What else can I show you on that? I thought I had a, maybe this one doesn't have that. I thought I could set different colour scales. Might be a different thing on the firmware for that. Might be my scope's got that. Unless I'm remembering it wrong, I don't know. I just set mine and forget it. So it's like it's one of these things which is always on my scope. Okay. Actually, let's go back to persistence. Go back to 1 second. I just like to have a little bit of persistence on there. Right, but that's why you do that. Now, hand modulation back off again, and you go back to a nice waveform. Okay, so it's got lots of nice features on it, and it's quite fast. Now, when I was going through this with Rob earlier on, he was familiarising me a little bit with this, and just covered a couple of little things with me just to remind me about certain features it has, such as the FFT. And one of the things I did show out was that the FFT was faster than some of the other scopes he had there. So this is processing power wise, it does seem to be more powerful in real time. So let's look at some other stuff. Require menu, memory depth. So in this mode I've got 7 meg there. Right, if I turn channel 2 off I might get some more. 50 ohm. What am I looking for? I just lost it. Here we go. So that's doing 7 meg in that range. Turn it off. Now I've got 14 meg, right? So it's sharing that between 2 channels. So if you've got both channels on, you get 7. Single channel, you get 14. Alright, so that's pretty good. You know, my scope here for the same thing, I've currently got sitting. I can go up to 35 in that one, but that's, you know, in that regardless, it's currently, because it's not doing anything, it can do full 35. But often I'm using it, I only got 1.4. Right, so no use only sitting on that one, depending on what function I'm doing, because it actually scales it back. But apparently this one doesn't do that, because it's got more processing power there. It can actually do more. And from what I've seen from its speed, it's been pretty good. So what else can we do? So you can turn sound on and off. I like to have sound on. What other stuff can I see in here? In-out functions. So you can do USB LAN, obviously. You can choose which one you want to use. Normal triggering. Actually, go to page 3. So options. Maybe it's not there. Screensaver function as well, obviously. So let's go to measurements. So you can do all typical measurements across the bottom here as you can on the other versions, because the firmware is very similar, but it is different in a few little places. It's not always obvious. So you've got the all measure feature here, which shows you all the various stats and what it's doing right now. Okay. As I said, I'm feeding in a 10 megahertz signal off my Marconi, and you can see the frequency here. Hopefully you can see that. It says 10 megahertz, 10.0000. Now, how that is for rounding, I don't know. Let's just put in a slightly different frequency. Let's put that in. So that showed that, yep. So, sorry, I'm nudging the cables a little bit. So I've got now at 10 megahertz with 5 kilohertz, right? So that's what's showing on display, which is great. So it's just changes. I just want to see how accurate this frequency counter, because one of my little things is having an accurate frequency counter, because for me that's quite important. So let's just do another little check there. Let's go even lower than that. Okay, yeah, that's reading bang on. So I've now done 10 megahertz, 0.5 kilohertz, right? And that's reading that. So that is actually quite impressive. I do like that. When I first got the SDS1202, the frequency counter wasn't accurate, and they actually addressed that in the later firmware update, and they corrected that, and it's made it much closer. It's only a couple of hertz out now, I think. Whereas this one here is looking really good. It looks like what it's actually reading is believable. They actually got the correct number of decimal places, whereas I think on that one there it's actually got too many decimal places, so it doesn't actually give you a true reading. It's rounded, but yeah. So this one's looking nice. Let's go a bit further than that, shall we? 10.0001. Yep, reads it. So that frequency counter there, you can trust it. Right. So let's try a big frequency step. Let's go 100 megahertz. 100 megahertz, bang on. Great, that is awesome. Okay. 200 megahertz. Now it's struggling with that a little bit. So it's a 200 megahertz scope. I'll put the input level up slightly, because I'm getting some losses through cables and stuff, you know, as you get. So yeah, still reading bang on 200 megahertz. So that's great. Let's just increase the time base. Just turn persistence off. Now that's the one of the features in this as well. You can push this button, you get persistence. If you push it again, you can turn it off. So that's really nice, a nice little shortcut. You also can do it in the menu as well, but it just means you can just do that and it's off. That's it. It's nice and quick. Okay, so 200 megahertz I'm feeding in, and we are. So I really should set these up in the bottom here. Measure. Type. Let's turn some more on. So let's see. I want IMS, and I like to have frequency on as well, because that's handy sometimes. And let's chuck in rise time for the hell of it. Okay. Right. So there we go. We've got those across the bottom there. Right. So we've got product, which I should turn off actually. RMS, frequency, and rise time. So this frequency here is based on measuring the waveform. I think that's a hardware frequency counter, which is there's a difference between the two. Right, so I'm impressed with the hardware one. That's good. That is really nice. Okay, so what was I going to look at now? I was going to look at IMS is showing 510 millivolts or so. Right, and my Marconi says it's putting out 500. So yeah, that's looking good. So let's just push this frequency range a bit further, shall we? Let's go 250 megahertz. Still there, but the levels dropped down to 380 now. Alright, so obviously you're getting that drop off. 300 megahertz. Still there. I think. No, that's dropped off, I think. There we go. This is just the trigger level. So that's saying 280 now. And that's a 300 megahertz. So it's usable at those frequencies. Let's try 350. It's still there, but now it's saying 200 millivolts to 205 millivolts. Right, I'm putting out 500 millivolts. So you know, the fact that it's still can see those frequencies, you know, is good. You know, that's 400 megahertz. Increase this level slightly now, and so you can change his colours too, but I'll turn the colour off for now. Right, back to, let's just change this. I don't like that. What's that one I'm looking for? No, I can't see it. I'm getting screen blindness. I don't see it. Why don't I see it? Anyway, never mind. Yeah, so there you go. It's there, and it can still see a 400 megahertz signal. You know, that's good. So let's go 450. Obviously you can't get accurate measurements for it. That's a 450 megahertz signal, and you can see it's starting to struggle a little bit now. Now I'm at the fastest time base. Right, 500, and you know that's that's getting aliasing now. Right, so that is really, you know, that's too much for it really. Right, so 400. Yeah, we're getting a bit of aliasing at 400 and stuff like that. So 350 is looking much better. Right, 300 again. There we go. 300 is looking quite clean. So even that, you know, it's a 200 megahertz scope, and you can see that it's usable at frequencies above that. You know, so that's a good bonus. You know, obviously the bandwidth is based upon the 3 dB down point and stuff like that. So, but I'm not going to go and measure in that. I'm not an electronics tech. I'm a hobbyist. You know, and I'm just going to play with the scope and show you what I find. Okay, so it's back to 250 megahertz, 200 megahertz. You can see the gains coming up. Okay, and let's do it back to 100 megahertz again. All right, got time base back a bit. So yeah, it's all looking good. I mean, the IMS is saying it's 785 now. So I don't know if this is great or not, but my Marconi output, but you can see it's all looking nice and clean again now. All right. But yeah, there will be losses through cables and so on. I'm using it's set to times 10 as well. Oh, it doesn't fall out. My socket up there is a bit loose. So yeah, so that's all nice. So that's the basic function there. Obviously you've got cursors and stuff in here too. Let's turn these measurements off. So you can do cursor measurements. This isn't something I tend to use myself. This is why I probably don't use it right. Let's go between one waveform. Right, so that'll give you. Let's go to the same place. So here it's got the frequency there. Other data which I don't actually know. Delta X. I don't know. It's not stuff I know. I'm not an electronics tech, you know. Come on. So, but it's got it. You know, it's got these functions you can do there. I think you can do Y cursors as well, so you can do the height Y's instead. You can do X Y. You can do both at once. Yeah, you've got the automatic cursings as well. So yeah, that's all good. Save and recall, so you can save and recall setups. And one of the things you can actually do, if you've got a setup you use frequently, such in this case I'm going to turn basic measurements on. I don't want all measure on. I'll just leave that off. Obviously keep the ones along the bottom. Statistics on, which tells you a bit more detail here. Right, this is one I tend to use myself on the other scope because it gives you some really good data. You know, you can choose which one you want to use. Again, same based off this. So you know, it's good. I'll turn it back off again. Other things you can do. Let's see. What can I show you? Oh, yeah, save and recall. I'll show you that. Right. So if you want to do a save, you can push that button there. You can save the setup to internal external memory usually, and you can save setup numbers as well. You can also save setup, reference, bitmap, JPEG, PNG, binary, CSV, MATLAB, and to default key. So if you have a setup you lose frequently, as I was saying just now, you can actually configure the scope as you want to use it on like a daily basis, or you know what your typical setup would be, and then you can do a save to default. And when you do that, when you push the default button, that's what it loads. So it loads the setup as you save it. So this is obviously the default setup as it is now. So in this case, it's not what I want. Need to go a bit faster with that, right? And turn channel 2 off. Okay, in this case, right? And bring that level down. So you know, all these buttons they're all push buttons. All of them are push buttons, so they've got multiple functions. Right, so you've got fine adjustment on these, on both of them. If that's turned on, horizontal, you've got zoom on there. All right, so if you've got a fast waveform, let's go back out of that for a second. If I do this, make it really compressed, then you go zoom. You can actually then zoom in, and you can go right back out to the same as the original, but you can slow it down. Right, so you can zoom into the part of the waveform, and it's just on that button press right there, and it's nice and easy, nice and quick to get to. You see how quick and responsive this is. You know, it works nicely. So along with the save, you can also recall setups, obviously. Right, so we go back into there again. Instead of doing saving, do a recall. All right, so you can set your recall setups, factory defaults, and reference. Also use if you're doing reference data of some kind. I haven't looked into that part of it yet. Okay, and all kinds of options. Right, I'm not going to recall anything right now. And you also have the print here, right? So let's bring this back down again, and let's bring that back down. So print. So if you want to take a screenshot, you can hit print. No, I haven't got a flash drive plugged in. Yeah. Okay, I'll have to get a flash drive for it. I can show you that. But if you push print, it then brings up an option. I'll show you this one. Alright, so here's my scope here. It works the same way. Okay, so I want to print on this scope, and it's saving it just like that. Done. Alright. Obviously, I haven't got this configured correctly right now. It's a bit of a mess. So yeah, let's load it back up again. Alright, so that was a save it. Hit print, it just saves it. And apparently the default screenshot format is now changed to PNG instead. So that's a nicer format to see. What else can I show you? Obviously, as I showed you with the change of memory depth, acquisition modes, normal, peak detect, average, and high res, or E-res as they call it on here. So you may be familiar with those. They can be good for getting rid of noise or cleaning up signals. You know, if you're trying to do certain kinds of measurement types. XY mode, obviously. Sequencing, so you can actually save segments. I haven't played with that myself yet, but it's like segmented memory, so you can actually take the capture from there, leave a gap, take a capture from that bit whenever there's a next trigger, things like that. So instead of filling up memory with a whole bunch of dead space where there's nothing going on, you only capture the relevant bits which you're actually trying to see. So if you've got triggers seconds apart, you can capture one, capture the other one, and not get the dead space in between the two. So that's what that's used for, but it's not something I've actually used myself. Okay, I think I've covered a fair bit. Decoding, well, it's got the protocols here. You've got two decoding there, right? Same as the other series. ranges I2C, or I squared C, you want to call it, SPI, UART, candle in. Right, so I actually have a test board here which I'm going to show you when I do my follow up to this video, and it shows some. I've basically programmed an Arduino to generate some serial protocols, which I'm then again going to feed into the scope and show you the outputs and how to use it. Alright, so you got the various, you can set channels and the thresholds, and for that particular I2C or I squared C, done SPI. You can set the clock and again what kind of edges and rising and falling edge thresholds, which channel you're going to use. Obviously I've got channel 2 turned off and not used, it's not going to show up right now. Alright, but you can set the same for that one there, Mozzie as well, and chip select. This is a really handy feature on this. You got chip select options there, and also which channel you're going to use, like 1 or 2. And you got clock timeout. This one's really handy if you're just going to do it on timing. Because it's 2 channel, they might be able to use external. I'm not sure, I haven't looked into this, but I need to look into whether the external will act as a trigger or not for the chip select. I suspect not, because it didn't come up as an option. But when you got 2 channels, SPI needs 3 inputs, right? Chip select, clock, and data. So what you can do with this clock timeout is you set a timeout limit, and then as you increase that timeout limit, you can then tell it to capture just the packet you're trying to find, and then that turns that chip select on and off based on timing from the original trigger, and that's really handy for doing that kind of thing. Especially if you've only got 2 channels, it's a requirement pretty much. All right, so I'll show you that. I'll do the decoding stuff later on. Okay, UART again. You got the signal options there, channel 1 or channel 2, whichever one. Obviously, you could say it's turned off right now. I'll turn it on so I can show you. So then you can select channel 1 and channel 2. So you can have RX on one channel, TX on one channel. Again, you set the thresholds for the triggering. So you can set the range. If you only like a 3.3 volt bus, a 5 volt bus, for example, then you can set it to a nice medium point. So you make sure you get accurate readings from that. Configuration, obviously then you can check. You can set the baud rates, 600 up to 115200, 115,000, right? Standard baud rates. There's also, you can set a custom baud rate as well. You set data lengths, right? So 5 to 8, parity, none, odd, even. Stop bits, typical, and high to low level, right? So where its normal idle level is. Sometimes idle level is high, sometimes idle level is low. Usually it's high. And bit order often is LSB rather than MSB. Right, so and you can also turn the display on and off for the decoding here. Okay, so that's a nice little overview. I think that'll do for now. I'll come back to it later on and do a bit more detail and a bit more depth, showing more stuff being done. Okay, so have a good one. If you like it, give us a thumbs up, share the video, because I'm sure lots of people want to see this thing in action. And thanks to Rob for supplying me this on loan so I can have a play with it. Awesome, good stuff. Remember, if you want one of these and you're in New Zealand, get hold of Rob. Alright, so as I showed you at the very beginning of the video, it showed his card on the top of the box. Look that up, go and give him a ring, email him, go to the website, whatever you want to do. He's got some of these in stock right now. Okay, so if you want one, get hold of him. Catch you later.